Okay. Uh, what we have discussed yesterday is probability mass function, and then for the discrete random variables, right? Yesterday we have discussed that, right? So, what is important over here? You have to remember that. I think Ajay is waiting in that room. Let me admit him. So, what we have discussed first, for continuous random variable, our fx basically satisfies these properties, right? Already we have discussed yesterday, right? And what is important over here, for continuous random variable, f of x is not a probability and it is a density. You have to remember this. And probabilities are areas under the curve, right? If I'll go to the detailed lecture notes. If you see over here, okay, this example we did, right? And these are the three important, you can say, every valid PDF probability density function must satisfy this. Function must be non-negative. Total area under the curve must be equal to 1. Okay. Then probability in an interval will be equal to area under the curve, right? Probability x takes the greater than a and less than b. So if you will integrate it, then you will find the probability in an interval, right? And something, what is f of x over here? Chinmay? Fx is,
Sample space of
no, no,
f of x is
no, no, no. Here it is written. Just now I told you, isn't it? F of x is, in red it is written.
it's a continuous random variable, not a probability. It is a density.
This is a density. F of x is not a probability. Okay, it is a density.
Density.
Yes. So similarly, you can find the cumulative distribution function. Okay, and there is a relationship also between PDF and PMF. Okay, so I think that will be little out of the uh, like syllabus or purview of the course. So let us see this numerical we did. And this is the comparison. Already I think we did. Now I think this is a very important part before you move for distribution, because in the slides it is straight away it is starting from the important discrete distributions. So these are the very important Bernoulli distribution. These are the discrete distribution. So you have probability distribution for discrete random variable and probability distribution for continuous random variable. Okay. So some of the important discrete distributions: Bernoulli distributions, binomial distributions, Poisson distributions, geometric distributions, hypergeometric distributions, and negative binomial distributions. So 6. Okay. So the first 4 are most important for the exam. Clear? Sangeeta, you have studied all this? These 4?
No, sir.
Long back. Long back, right?
I don't remember, sir.
Yeah, not a problem. So we'll review again. So if you'll see over here, so before we discuss actually, you can say the probability distribution, discrete probability distributions. So something is very important. This is expectations. We write like this: expected value, right? So what is expectation, Chinmay?
Hmm. Ex- expectations. Mm,
Is Madhusita?
sir, we have we do the random experiment more than one time, and in that same time we find out the long term average result of the random event, then that is the expected value.
That is correct. But in simple language, always try to tell the simple language. So expectations is basically style. It's an operator similar to like plus, minus, which we use in mathematics. So in statistics, it is an operator. It is an operator for the random variables. Are you getting?
Yes, sir.
So E is basically an operator, the statistical operator. Okay. So
Yes.
that is in long definition what you told, that is fine, but ideally it is considered to be an operator similar to like addition, subtraction. So in terms of statistics for random variables we use this. Okay, expected value or expectations. So what is expectation? Expectation is the average value we expect from a random variable. If we could repeat the experiment many times, it is also called the mean, or we usually denote the expected value of x or mu. So think of expectation as the center of gravity or balance point of the probability distribution. So can you give one example, Sangeeta?
The real life example?
Yes. Of expectations. The definition. The application of the expectations definition. Suppose, for example, if the students, let's say that we will ask the on an average, what is the percentage or what is the CGPA of the students of Department of Economics in Government Women's College? Okay, on an average, how much CGPA they have got over the years, right? So that is nothing but the mean value, right, or average value. You getting? So this is nothing but the center of gravity or balance point. Or you can say expected value of x. Clear? Sangeeta?
Yes, sir.
So that is actually when we are taking repeated samples, right? When you will take average, so that average will converge, okay? And that's what it is written. If we could repeat the experiment many times, like what we will do is, we'll go back and we will see in the last 20 years what is the actually CGPA or percentage what you can say achieved by the students, right? So then that average will be nothing called mean, or it is the average value. Okay. So why is expectation important? Expectation tells us to expect on average in the long run. I asked you, na? On average, right? We asked these questions in real life, right? So to make prediction, to compare different scenario and make decisions under uncertainty. Okay. So let's say that everyday understanding how you will relate it. Suppose your college is 5 kilometers from home. Your travel time varies, sometimes 20 minutes, sometimes 30 minutes, sometimes 40 minutes. So the expected travel time is the average you would experience over many days, right? If you track it for 100 days and average them, that is approximately the expectation. Is it clear, Sangeeta, now?
Yes. Yes, sir.
Okay. So it's basically it's a kind of long run average. Okay.
Yes, sir.
So calculating now, calculating expectation for discrete variables. Okay, so I will be little fast over here. So please try to understand it much faster. So for a discrete random variable x, expected value of x will be equal to summation x into, already I told you what is this x, right? Then x into probability of x takes the values of small x. Clear? Is it clear this one? This x is what exactly? Madhusudha, quickly. The small x.
Sir, random variable.
Specific values of the random variable. Specific. Random variable is
Capital X
capital
is
X. Capital X is RB. I am asking about small x, na? Specific values of random variable, isn't
Random.
it?
Yes, sir.
X is random variable. You get it? Suppose when you are throwing a
Yes, sir.
dice. So 1, 2, 3, 4, 5, 6. These are small x. Capital X is your throwing a die. So simply what this formula is telling you, you have to take each possible value. Even though you are having lecture notes, I am telling you, when you are attending the lecture, please take a note. Okay, whenever at least the formula, so that you will be able to practice. Are you taking the notes, Sangeeta?
Yes, sir.
Okay, very good. Chinmay?
Yes, sir. Yes, sir.
Okay. So, what you have to do is, in simple words, this formula means what? You take each possible values and you have to multiply it by the probability, then add all these products together, then you have to sum it up. So let us see, we'll see one example. So one example is fair die, right? So then our random variable capital X is the number on a fair die. Okay, so you have to list all the values and probability. So small x is the specific values of x. So small x it will take from 1 to 6, right? 1, 2, 3, 4, 5, 6. And probability of x equals to small x will be 1 upon 6, isn't it? Then what you have to do is, you have to multiply each value by its probability. X into probability of x, it was written earlier, isn't it?
Yes, sir.
Yes, sir.
Then what you have to do, you have to just sum it up. Okay, if you sum
Yes,
it up,
sir.
what you got 3.5, right? So what will be the interpretation? If you roll a die many times, the average value will be close to 3.5, right? Even though usually it doesn't make sense, because 3.5 we are not actually sure that there is no side which is marked as 3.5, right? But that is the expected value. Are you getting?
Yes, sir.
क्योंकि हमारे डाई में 1 to 6 तक रहता है, right? So 3 is not the 3.5, so it will be not there, right? But that is
Yes,
the
sir.
average value. Similarly, you can see, you play a game where you roll a die and win money based on the number, right? So this is also, this you can target, means try to solve it in home, okay? Because it is similar, right? I'll straight away go to the properties of expectations, okay?
Yes, sir.
So what are the properties of expectation? So expectation of a constant is constant itself, okay? So if your x is always the same value, okay, then it means there is no randomness, then its expectation is C. Are you getting? So what this says, this formula says, suppose if you will take the constant 2, the expectation of a constant will be 2 itself. Are you getting?
Yes, sir.
Yes, sir.
Sangeeta?
Yes, sir.
It means if you will take, means suppose let's say that you are, every time you are reaching the campus from your home within 5 means in 5 minutes only. Then 5, it is not changing, okay? All the time it is 5 only. So then expectation of 5 will be 5 only, right?
Yes, sir.
So that is what it is written. If x is equal to 5 always, then x will be 5. Second property is property number 2, linear property. Expected value of ax plus b will be equal to a into expected value of x plus b. Okay? So this is a linear property where a and b are constant. Now it is giving one example. Let's say that average mark in a test is 60, so expected value of x is equal to 60. Now teacher adds 5 grace mark to everyone. New marks will be x plus 5. So you will write like this: expected value of x plus 5. So that is expected value of x plus 5. Earlier what we had? We had 60 plus 5. So there is no need of calculating again the whole average. Are you getting my point?
Yes, sir.
Similarly, case number 2, you can see over here. Teacher double everyone's marks. New marks is 2x. So expected value of 2x will be 2 times expected value of x. Right? So basically this is change of scale, isn't it?
Yes, sir.
Then case number 3. What is happening, Sangeeta?
Doubles the marks, then adds 10.
Very good. So basically both change of origin and change of scale.
Yes, sir.
Okay. So the main point is, so you don't have to do it again the whole calculation. Just if you know the formula, then you will be able to do it. Okay.
Yes, sir.
That is most important. The
Linear.
next property is
Summation.
summation property. Expected value of x plus y will be equal to expected value of x plus expected value of y. Right? It means expected value of a sum equals the sum of expected value. Like for example, you take 2 tests, right? Expected marks in test 1 is 70. Expected marks in test 2 is 80. Then expected total mark will be expected value of x plus y, that is 150. Okay? Clear?
Yes, sir.
Now we will go quickly to binomial distribution, right?
Yes, sir.
Before that, I think Bernoulli, it is there or not, I don't know. So let us go to Bernoulli and then binomial. Okay? So please you write here, yeah. So a random variable x follows Bernoulli distribution. We say Bernoulli trial. You have remember Bernoulli trial?
No, sir.
Chinmay,
No, sir. No.
what do you know about Bernoulli distribution? You know anything about Bernoulli distribution, or you don't know anything about Bernoulli distribution? Or you know something?
Sir, only I know the formula.
The formula which is written over here?
Yes, sir.
Madhusudha?
Actually, I don't know about.
Okay, first of all, let me write it, because everything is not there. That is why I asked you questions. Okay, so accordingly I have to write, just to make sure you understand. Okay, so basically Bernoulli distribution is the most simplest discrete probability distribution. Okay, so what it basically tells you, it describes outcome of a single trial. Outcome of a single trial. single
Mm.
thread. Okay, that has only two possible outcomes. Only two possible
Okay.
outcomes. Is it clear?
Yes, sir.
So, what is a Bernoulli distribution? Bernoulli distribution is a discrete probability distribution which describes the outcome of a single trial that has two possible outcomes. Like success, we write success is, let's say that 1, right? Then we will say the probability is P. Then failure
Failure is 0.
is 0. Then the probability is 1 minus P.
1 minus
P.
1 minus p. 1 minus p.
Then the probability will be greater than equal to 0 and less than equal to 1.
1.
Okay? And how you write? See, there are many things you should know. Okay, I will write in this white space. How you will write probability mass function so that it will be a little practice for you guys. So how you do write probability mass function? PMF of a Bernoulli. Madhusudan,
Sir,
you will be able to write the PMF of a Bernoulli random variable.
sorry, sir.
Bernoulli random variable x. Okay, how you will write? You will write like this: probability of x, takes the value of small x. Okay, is equal to P if x is equal to 1. Okay, and 1 minus P if x is equal to 0. Clear? Or more compact form. Okay, we write like this: x is equal to small x will be equal to probability of x into 1 minus P 1 minus x. Okay, and x belongs to 0, 1. Is it clear?
Yes, sir.
Yeah.
Okay. So that is what it is written over here. I have little expanded, right? So, but here it is straight away directly given. Is it clear? Sangita,
Yes, sir.
how to write probability mass function of a Bernoulli trial or Bernoulli random variable? I have told you. Then what else I told you? Okay. Now notation is like this. Okay, Bernoulli bracket it is P. It means it is a function of P. Okay. So what are the parameters over here? Mean is expected value of x. We will write like this. That is P. Variance of x will be P into 1 minus P. That is P times Q. And standard deviation is root PQ. Clear? Sangita?
Yes, sir.
See, every probability distribution, what is important, you know? Mean variance. Because if you know the variance, you can easily find out the standard deviation. So for
Yes, sir.
every probability distribution, you should know what is the mean and what is the variance.
Variance.
Okay, so now standard deviation we can out, right? So that's what it is given over here. Tossing a coin once as x is equal to 1 if it heads and x is equal to 0 if it tails, right? With probability of 0.5. Already you know this. Then you see when you do n Bernoulli trials, it becomes binomial distribution. You just see. So there is a logic. So the mean will be np. The variance will be n times pq. Let us see if it is yes or no. npq. Okay, clear?
Yes, sir.
In
Yes,
case of
sir.
in case of Bernoulli, it was only p. But when we do n times a number of success in independent Bernoulli trials, then it will be uh, binomial distribution. Okay, clear? Similarly, Poisson distribution. Let's see if there is anything which we have left out. Yeah. So let us see what it is saying. This is maybe something interesting. Let's see. Till here we know the binomial distribution is one of the most important probability distribution. That is why you need to understand it thoroughly. What is binomial distribution? We use binomial distribution when we perform a fixed number of trials. Each trial has only two possible outcomes. Then the probability of success is the same for every trial, and all trials are independent. These are very important. Okay, and we say we like X follows binomial distribution with n trials and p probability. Okay, so that is what it is written over here. X follows a binomial distribution with n trials and probability p. Clear? How you will read it? Sangeeta, is it clear?
Yes, sir.
Then real life example of binomial situation. Coin tossing. Experiment is toss a coin 10 times. Okay. So there are two outcomes, like each time head or tail, right? So fixed trial is n is equal to 10. Okay, the probability is p 0.5, right? For a fair coin. Now question is how many heads will we get? This is binomial 10 times, right? And then the you can say it was written right. What is it? Yeah. So n p na, right? N is 10 and this is p
0.
0.5, that is p. Okay. So similarly you can check for the other cases. So the binomial formula, what it is telling, the probability of getting exactly x success in n trial, okay, so is, so n choose x, okay, like this we say n choose x. Basically it is number of ways to arrange x success in n trials. Okay, so how you will find out? P to the power x into 1 minus p to the power n minus x. Okay, so p to the power x is probability of x success, and 1 minus p to the power n minus x is probability of n minus x failures. So x can be 0 to n. Okay, now question is you don't have to panic over here, so you can use many nowadays statistical table calculators to find out the probabilities. So what are the key properties of the binomial distribution? mean value, expected value of x is equal to np, right? This is very interesting example. If you toss a coin, just give me a minute. I'm just coming back. 1 second. Please read this till the time. Okay. Is the screen visible?
Yes, sir.
Screen is visible, right?
Yes.
So what it is written? If you, Sangeeta, is the screen visible?
Yes, sir.
Okay, if you will toss a coin 100 times, what will happen? You will write like this: n is equal to 100, probability is 0.5, right? Expected value, expected heads will be n into p, na? Right?
Yes, sir.
So 100 into 0.5, that is 50. So it makes sense, right? So 50 times you will get head, and 50 times you will get tail. Is this fine? Similarly, variance np into n1 minus p. There might be short question. Okay, just 1 minute. I'm coming. So what you can do is, you can do a like experiment. It will be very interesting. Okay, Sangeeta, what you will do
Yes, sir.
is you take a coin. Okay,
Hmm.
each time you write, you toss 20 times or 10 times or 30 times, write whatever you are getting, and you see whether you are getting heads 50 times or not. Means 50 times means 50 percentage. Basically, if it is 20, then it should be how much? 10 times. We will do this experiment, okay, together. Okay.
Yes, sir.
Then it will be interesting. You will not forget binomial distribution. So then variance formula is variance of x, which is equal to np into 1 minus p. So variance measures how spread out the values are from the mean. Similarly, standard deviation. So standard deviation is easier to interpret than variance. It is the same unit as x. So this one example is given over here. Okay. A basketball player has 70% free throw success rate. So all these informations are given over here. Please do the work. Okay. And you just let me know if you are able to understand or not. Straight away, huh? The formulas are straight away. You want me to solve it, or Sangeeta, you will go through it?
Sir, we will go through it once, then if not possible, then we will take your help.
Okay, very good. So when not to use binomial? The binomial distribution doesn't apply if number of trials is not fixed. So in that case, you will go for Poisson distribution. Then probability changes from trial to trial, and there are more than 2 outcomes per trial. Okay, and trials are not independent. Trials are not independent. Okay, so now we will move to Poisson distribution. Then now next question is, what is Poisson distribution? Poisson distribution is used for counting the number of events that occur in a fixed interval of time or space. And second, when events occur randomly and independently, and when we know the average rate, that is lambda, at which events occur. Don't worry, we'll do some numerical to understand it. But before that, let's understand a few more things. So what we write, how we write? Poisson, x is equal to Poisson, a function of lambda, where lambda is the average number of events. Okay, clear? Now, so what this first example is, customer arrivals. A bank receives an average of 4 customers per hour. Now question is how many customers in the next hour? So lambda is equal to 4 over here. So x is nothing but the random variable that is following the Poisson distribution of 4. We write like this. Okay. It's a basically Poisson situation. Are you getting? Suppose you are receiving an average of 10 emails per day. Now question is how many emails you will receive tomorrow. So it is very interesting. Are you getting? Sangeeta?
Yes, sir.
These examples are Poisson situation. So it is not poison, okay? Poison जहर होता है. That is different. So it is not जहर. हाँ? संगीता?
Yes, sir.
हाँ. वो अलग है. Poison situation. This is very
Yes, right.
interesting. Suppose when you ask like these questions, right? So, but you see, we have some idea, right? You receive on an average 10 emails per day. Suppose, for example, can you give me quickly one example where example of Poisson situation? Quickly. Sangeeta?
Sir, I take 5 minutes to reach college every day. So the probability of reaching tomorrow is also 5 minutes.
Chinmay?
Am I audible, sir?
Yeah, you are audible.
Yes.
I think that is not a typical case, huh? Because the number here only one number, na? Isn't it?
Sir, how many students come from next
Sangeeta, you are
to
how many students where they will come?
from college, sir?
From college to where? Tell me clearly.
Sir, how many students
Uh,
come to school college from their home in 15 days?
no, you did. I think you guys are making very complicated because you didn't understand what is Poisson distribution then. Poisson distribution is used for counting the number of events that occur in a fixed interval of time or space. And when event occurs randomly and independently. Okay? And when we know the average rate lambda at which the events will occur. Are you getting? So, now let me tell you, rephrase, okay? Sangeeta, regarding your answer, so that is not purely Poisson distribution case. Okay?
Okay, sir.
Why? You should say, because there are only one person only. You are not trying to ask. You should be able to like ask. Are you getting my point? This type of questions. Now question is like, for example, I will tell you. Suppose how many today you received how many calls? Let's say that 5. Okay. Then how many calls you will receive tomorrow? That is a Poisson distribution. Now let's say that 5th semester students, the 5 students come today. Okay. Then how many students will come tomorrow? That is a Poisson distribution.
Yes, sir.
Clear?
Yes, sir.
So now you should actually, because how you can identify this and why I am saying your answer is not correct. So you should know that what makes something a Poisson process. So this process is basically the data generating process is called Poisson process. Okay? It means what? The events are random. It means we cannot predict exactly when they will occur. Okay?
Yes, sir.
Events are random. But when you are coming from your home to college, is it random?
No, sir.
Now you got it, right?
Yes, sir.
Chinmay, in your
Yes,
case,
sir. Yes, sir.
you
Yes,
are,
sir.
you are saying how many are coming from school to college?
Yeah, sir.
Then tell me quickly what you told. I forgot.
Sir, how many students come to college
Uh,
to their home in 15 days? I think.
that is, you are just making it complicated, little complicated. Yes, they are approximate. How many students will come from their home to college in next 15 days? Okay,
Yes, sir.
you are saying like something like that. Yeah, kind of, but yes, you can make it much simple. Huh?
Okay,
So,
sir.
because we cannot, so events are not random over here. Okay. Uh, yeah, your answer is close, but it's not very good answer. Okay. So to know that, you should be able to differentiate. Events are random. Whatever your answer, if you are able to justify these four properties, then it is fine. Then
Okay, sir.
events are independent. One event doesn't affect the other. Events are rare. In any small time interval, probability of multiple event is very small. Then constant average rate. The average doesn't change over time. Okay? Is it clear?
Yes, sir.
Then how we will write Poisson formula? We write like this: e to the power minus lambda, lambda to the power x upon x factorial. Okay? So usually we write like this. So don't worry about the formula. You don't have to mug it up. If the question will not come, then leave it. But don't get worried. What you have to remember is only expected value mean of Poisson distribution is lambda. Only you have to remember this. Variance of x, if x is a random variable and it is following Poisson distribution, it is lambda only. Okay, so only you need to remember one parameter lambda for Poisson compared to 2 in for binomial. One for Poisson, 2 for, that is n and p for binomial. Is it clear, Sangeeta?
Yes, sir.
Now next one example is given over there. So quickly do it. Okay. So a call center receives an average of 5 calls per hour and calls arrive randomly. Okay. So Chinmay, in your case, why I told that it is not a good example? Are the students coming randomly? If it is yes, then it is fine. Okay.
Yes, sir.
Given the information lambda is equal to 5 average calls per hour, x is equal to number of calls in an hour, x follows the Poisson distribution. Question number 1. What is the expected number of calls per hour? How you will find out? Similarly,
Expected of x in
is equal to lambda. So lambda is nothing but 5. So answer is 5 calls per hour. Clear? Question
yes.
number 2. Find the variance and standard deviation. Variance of x is lambda again. Same thing. Standard deviation is just root of lambda. So it is 2.24. Clear? Then what will be the interpretation of this 2.24? The number of calls typically varies about 2.24 from the mean. Most hours will have between 3 and 7 calls, that is roughly mean plus or minus 1 standard deviation. Okay. Is it clear?
Yes, sir.
Yes, sir.
Similarly, you have to write you want to find out what is the probability of receiving exactly 3 calls in an hour, so you have to write like this. Just you have to replace, okay, and then you have to calculate. But I think this e to the power minus lambda to the power x upon x factor. Just you have to remember that much only. Okay. Now we have done binomial, Poisson. So these are very important distributions. Okay. When n is large, p is small. In a binomial, it approximate Poisson distribution with lambda is equal to np. This is a very important point. When n is large and p is small for binomial distribution. Okay. Clear? Clear, Chinmay?
Yes, sir.
Now next we will go to normal distribution. So this is normal distribution. So normal is an important distribution in statistics, right? Then what is a normal distribution? The normal distribution is also called Gaussian distribution. It is a continuous probability distribution that has a bell-shaped curve. Have you seen the bell on the temple? Chinmay?
Yes, sir. Yes, sir.
So it look like this. I am not
Yes.
sure. It's not a perfect shape, right? But you should have a bell-shaped curve. It is perfectly symmetric around the mean, around its mean. Okay, symmetric around its mean. What do you mean by this? Symmetric around its mean? Means
Mean, sir.
what will be the skewness? And what will be the kurtosis value? Sangeeta, quickly.
Skewness is 0, sir.
Very good. What about kurtosis?
Kurtosis is
3.
3,
3.
sir.
Symmetric around mean means what? Mean is equal to median is equal to mode.
Equal to mode. Yes.
Mode.
Okay, and it is completely determined by 2 parameters, that is mean and variance. This is most important. Okay, normal distribution is completely determined by 2 parameters, that is mean mu and variance sigma square. Clear? And how you write? X follows normal distribution with mean mu and sigma square, the variance sigma square. So you will write like this: the random variable x follows normal distribution with mean mu and the variance sigma square. Clear? Chinmay, is it clear?
Yes, sir. Yes, sir.
Sangeeta, is it clear?
Yes, sir.
Madhusudha, is it clear?
Yes, sir.
Okay, very
Yes,
good.
sir.
Then why it is called normal? Because it appears extremely common in nature. Many natural phenomena follow this distribution, and it is the norm or the standard pattern we see everywhere. That is why it is called normal distribution. Okay. So what are the characteristics of normal distribution? It is a bell-shaped, symmetric, and unimodal. It has only one peak around its mean. So it is asymptotic. It means asymptotic means the graph will never touch the axis.
Was the x-axis.
Okay. Then as I told you, it is symmetric around means mean will be equal to median will be equal to mode. All three will be at the center only. Then what about the mean and standard deviation? Where they will appear? Mean will determine where the center of the curve is. The standard deviation determines how wide or narrow the curve is. Clear? So larger sigma means what? Wider or flatter curve, more spread. So it means, let's say that in this case it will be sigma is higher. Smaller sigma means narrower or
Taller curve.
taller curve, less spread. So this is a real life example. Can you just read out, Sangeeta?
Yes, sir.
Quick, quick.
I'll read it loud, sir.
Yes, yes.
Human characteristic: heights of people of same gender and age group, weights of people in a population, IQ scores in a population, blood pressure readings, shoe size.
Wait. So what this actually? In all these cases, they follow normal distribution. Okay? They follow normal distribution. Is it clear?
Yes, sir.
So why they follow normal distribution? The answer is here. Many natural phenomena result from the sum of the many small independent random factors. That is called central limit theorem. Okay? Explains why this leads to normal distribution. Why these characteristics, what you have studied or just you have read it, it is actually why these cases, all these cases they follow normal distribution, because of the central limit theorem. What is a central limit theorem? We'll discuss, not today, maybe sometimes later on, but you should know it. That is my whole point. Okay,
Yes, sir.
Sangeeta?
Yes, sir.
So what are the key properties of the normal distribution? Mean, what will be the mean? Mean is mu. Okay, so it is the center of the distribution. Variance is sigma square, standard deviation is sigma. So standard deviation determines the spreadness. So since it is symmetric around mean, so 50% will be below mean, 50% will be the above the mean. Okay, 50% of the area. Because it is like this, na? So this is around here, it is like mean will be equal to median will be equal to mode, right? This is 50% and this is 50%. Okay, so there is a rule called 68, 95, 99.7 rule. So this rule is going to be very useful in future. So what is this? What is this rule? This is most important rule for a normal distribution, which you should remember. 68, 95, 99.7 rule. For any normal distribution, 68% of the value lies within one standard deviation of the mean. That is mu minus sigma to mu plus sigma. Okay. Then 95% of the value lies within the two standard deviation of the mean. That is mu minus 2 sigma to mu plus 2 sigma. Okay. Then 99.7% of the values lie within 3 standard deviation of the mean, that is mu minus 3 sigma or mu plus 3 sigma. Is it clear?
Yes, sir.
So you have to memorize this 68, 95, 99.7.
7.
1, 2, 3. Mu plus 1 standard deviation, mu plus 2 standard deviation, mu plus 3 standard deviation. Okay?
Yes, sir.
Then there is this example is there. Please do it and let me know if you are able to understand it or not. Okay. Then once you complete this task, exercise, we will continue our discussion tomorrow, the daytime. Okay.
Yes,
Clear?
sir. Yes, sir.
So we'll do it tomorrow then. We'll stop over here. I think we are very close. Only standard, you can say, how many? Very less.
Central limit theorem is left.
Only comparing this three distribution and what is this called? Z score, standard normal distribution. Okay. Before that, you just try to attempt this one. Okay. 8.7. Then tomorrow it will be completed. Okay.
Yes, sir.
So there are numericals also there. So please try to see also that. So let me stop this.